Good morning, students. This is Mrs. Cindy, and I would like to talk to you about rational numbers, specifically fractions. So we're going to lay a little bit of groundwork for fractions in this section, talking about factorization, as it turns out. So prime factorization is section 5.1, and the reason why we're talking about this is kind of going to prepare us to get back into fractions over time. Okay, so definition, and what should be in your notes when this video is done, is definition of factors. Factors. They are numbers that you can multiply together to get another number. Okay, so for example, 5 times 3 is equal to 15, as you know. The factors of 15 are both 5 and 3. Okay, so these are your factors. Okay. Another example would be 6 times 10 would be another set of factors, and they get you to that 60 number. So this is a factor, this is a factor again, okay? So what's the difference between a factor and a prime factor is kind of what we're going to talk about. But to factor a number, you have done some practice problems like this, okay? It means to write it as a product of its factors. So for example, if we have the number 33, 33 when it is factored is 3 times 11, okay? So the factors of 33, that's the process of factoring a number, okay? So let's go ahead and move on and find out what prime factorization means. And I apologize, I realize that that is covered up. So what this word really is prime number. What is a prime number? It is any natural number greater than 1 that has no positive divisors other than 1 in itself. So for example, 3 would be an example of a prime number. And the reason for that is you cannot divide it by any other natural number to get you can't divide it by anything other than itself. So you could divide it by 3. You could divide and you would get a whole natural number, or you could divide it by 1 and you would get 3. So 3 is divisible by 3 in itself to get a natural number, okay? A composite number would be an example, and so that's why we would say that 3 is a prime number. Sorry, just to go back to that. Okay, a composite number is your example of something like 6. 6 is divisible by 6. It is divisible by 3. It is divisible by 2. It is even divisible by 1. Okay, the factors that kind of go into 6 are all of those. So a composite number is a number that is not prime, okay, and it's greater than 0. So a composite number is a number that can have a whole bunch of things go into it, okay? So what we're going to do is, and the way I think of prime numbers is you can't get any smaller than this. You can't break 3 apart into 2 other numbers, whereas 6 you can break apart into many different numbers, right? You could get it a lot of different ways. You could multiply a lot of different numbers to get to 6. 6 times 1, 3 times 2. It's not a lot, but it's still options. To get to 3, you can only do 3 times 1. Okay. So when we think about that, what is prime factorization? So I think this is going to get covered up too. Sorry about that. Okay, so what this word is that you can't see is prime factorization, okay? What this means is it's the process of finding the factors of a number that are all prime, okay? Meaning that we're going to break apart numbers to get to all the prime numbers that make it up, okay? So there are 2 ways to do this. The most familiar one and the one that I am way more comfortable with is the factor tree. Not to say anything about just using straight division, but I think visually, I'm more of a visual person, so that's very helpful for me. But division still works. I'm going to show you both so you can decide what is best for you, right? Because you are not me, luckily for you. Lucky for you. So let's move on to what a factor tree would look like. Oops. So a factor tree, gosh, I need to learn how to do that. So a factor tree, okay, looks something like this. If I were to factor, use prime factorization, factorization, the number 12. What I would do is I would say, okay, what makes up 12? What times what is equal to 12? And I could say, there may be a couple of options to get here, okay? 3 times 4, okay? What I'm going to do is I'm going to circle the primes to keep myself organized. So 4 is not a prime number; it's a composite number because it is made up of it's made up of more than one possible number other than itself and 1. But 3 is a prime number. Okay, so I'm going to circle the prime numbers that I come in contact with in my tree. So 4 is from the product of 2 and 2. Okay, so 2 times 2 is equal to 4. And these both are prime numbers. I can't put any other number other than 2 and 1 into 2 or 2. So these are 2 prime numbers as well. So ultimately 12, okay, is made up of, and the way that we kind of write the answer to this type of problem is the prime, and I'm okay if you do prime PF, prime factorization is equal to, in this case, we would say 3 times 2 times 2. Another way that you would be answering this is prime factorization in exponential form. And what that means is we're just going to kind of do a shorthand. So the other way that you would report this is 3 times 2 squared, sorry, because there's 2 of these. So 2 to the second power. Okay, this is prime factorization in exponential form, which is one way that you would be asked to do this. Okay, so I went, just to think about it, I went in one direction here. I did 3 times 4. I'm sure when we were doing this, some of you may have said another option for the factor tree of 2 times 6. Okay, let's see if we get the same answer if we do it a different way. So 2 is a prime number. 6 is a composite number made up of 2 times 3. 2 is another prime number, and 3 is a prime number. And so I would get the same thing. So the prime factorization for this 12 by taking this approach, I would get 2 times 2 times 3. And that's why circling is really important. So please circle your answers. Please circle the prime numbers that you encounter through your factor tree just to really keep yourself organized, okay? Let's look at another example, one that's less straightforward, okay? Moving on. Okay, what if we were to look at this number, okay? 585. Let's work through this one, okay? So I know that 585 must be divisible by, okay? If it ends in a 5 or a 0, I know that it's divisible by 5, okay? So I'm going to do a little scratch work here on the side. 585 divided by 5. Never done this on the computer before. 0, bring down the 8. 5 goes into 8 one time. Put a 5 there. Subtract 8 from 5, get 3. Bring this number down. 5 goes into 35 7 times. So I know that the beginning of my factor tree is going to be a 5 and a 117. Okay, let me get rid of that real quick for you. I haven't backed up my computer in a while, it seems. So what we've just done is oh, I didn't mean to circle this, sorry. That was not supposed to be circled. I got distracted, sorry about that. So we know that 5 is a prime number because you can't really get 5 from multiplying any numbers other than 5 in itself. Any whole numbers, I guess. But 117 is the question mark, okay? Is this a composite number? Is 117 a composite number, or is this a prime number? And here it's just kind of guessing, right? 117, if I divide 117 by, let's say I tried 2, so it goes in, 2 goes into 11 5 times to get 10. You get 1, you carry this down, 17. Does 2 go into 17? It does, but then you'd have to start adding decimals, and that's not, so 2 is not an option. But let's try and see if 3 goes into 117 here. 3 times 3 is 9. We get 2, bring down the 7. 3 goes into 27 9 times. So here we go. We have a 3 and times 39, okay? And then is 39 a composite number or is it a prime number? And since it has a 3 and a 9, I know I can put a 3 in there as well. So I know that that will work. If I divide 39 by 3, if you want me, I can do this on this side. 1, 3, 0, bring down the 9, 3. I know that it goes in 13 times. So here's another prime number, and then you have 13. And 13, can you put anything? Can you divide 13 by any? Can you get 13 by multiplying any numbers? And the answer is no. So 13 is another prime number. So ultimately, after this very long example, you would have your prime factorization in exponential form. Exponential form is equal to 5 times 3 squared times 13. Okay? It would also be correct to write it like this if you are not being asked to do it in exponential form. Okay? I like this way better because it sets us up for the future. I would say I don't like this way better, but this is the way that you'll see examples. Okay? So this is one way. This is a factor tree, and you may or may not find this most useful. So let's look at another example of division. Okay? So division, what you're being asked to do is to use, it's just highlighting these divisibility rules. So go ahead and write these in your notes. I know it may feel like busy work, but as you write it, you'll learn it a little bit. So you can pause me right here and do that. So let's go through and do an example of divisibility, of using division to find out about prime factorization. So if I have a 325, okay, the way that you set this up is you think to yourself, okay, is 325 divisible by anything? And as our last example, we saw that anything that ended in a 5 or a 0 was divisible by 5. So we would say divisible by 5. Okay, and so the way that we set it up is we make a line here, and then we make a line here, and we say 5 goes into 325. And when you do that extra step, 325 and 5, 6, 30, 2, bring down 5, we get 5. So we get 65 here. Okay. What is 65 divisible by? I would say again, divisible by 5. And so we would say you can divide by 5. So what you're doing is you're writing your prime numbers out here and your composite numbers inside. So it's 65 is divisible by 5. And so if you do 5 into 65, you get 1, 5, 1, bring down the 5, 1, 13. So we get 13 here. Okay, and this is now a prime number. And so what you do is you say when I divide 13 by 13, I will get 1. And so my prime numbers are 5, 5, 13. Okay, so you would report that as prime factorization equals 5 times 5 times 13. So you can't leave it up here. You really need to translate it into this. Okay. So what type of questions are you going to be asked on your homework? You'll be asked one of two questions. Number one will be tell whether or not a number is prime or composite. So you would look at these examples and say, is this a prime number or a composite number? Can I divide this? What are the numbers that I can multiply by each other in order to get 5? And really the only answers are 5 and 1, so this one would be a prime number. 18 is divisible by 2. 2 times 9 would be 18. So the fact that you can think of anything other than 1 in itself means that it is a composite number. And then write the prime factorization of each number in exponential form. So here, if you go to factor this, make a factor tree, you would just get 5 and 1. So that means that your prime factorization of this is just 5. You're kind of implying the 1. And then 18, you would do the same thing. 18, we said 2 times 9. We could have also done 6 times 3. And then this would be 3 times 3. And so here you have 1, 2, 3. So your prime factorization is 2 times 3 times 3. Or I think on your homework you're going to be asked about exponential form. Go ahead and do 2 times 3 squared. Okay, good luck. I'll see you in the next section.